Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 193 of a Momenta Digital Thread podcast series. Today, I'm pleased to host Martin Cloake, CEO of Raven.ai, the automated contextualization and OEE software for manufacturers. Raven is Momenta's most recent venture capital investment. Martin has over 20 years of industry leadership roles across manufacturing, data science, intellectual property, and operations management. He's an award-winning technology entrepreneur, holds multiple patents, and is a proliferate writer on topics such as Industry 4.0, leadership, manufacturing, and augmented management. He holds a bachelor's in mechanical engineering from McGill University in Montreal, Quebec. Martin, welcome to our Digital Thread podcast.
Thanks for having me.
Oh, yeah. Good to have you. It was interesting. I remember one of the earliest conversations we had before we discovered Raven from an investment perspective. And we had been kind of trading jibes because it seems like you've got actually a pretty popular community and podcast you do as well. And it was just kind of fun to get to know you pretty quickly in that vein. And of course, subsequently, we realized that you were sitting on a pretty hot company. And so we'll probably talk a little bit about both today. But this is called the Digital Thread podcast. And so I always like to start talking about one's digital thread. In other words, the one or more thematic threads that define their digital industry journey. What would you consider to be your digital thread?
Well, I think I'll describe what has made this stuff interesting for me in general. So I think one of the things that's always been part of my nature was constantly questioning, to the point early on in my life where it was just infuriating to have anybody around me. And as I sort of evolved through my education, got to the point where science and math gave me the most satisfying answers to those questions. So that's why I went sort of down the engineering path. And as I got into engineering, things started to seem really clear with regards to what I was interested in, and then how I would be able to do things in the workforce once graduating. Then, of course, I got recruited by a manufacturing company right out of university. And then when I hit the shop floor of a manufacturing plant, my world has changed somewhat, because my view of how things worked in the workforce, in the real world, was somewhat skewed. What I had expected manufacturing to be, based on my degree at McGill, a bunch of machines and data ready to be optimized by enthusiastic new grad engineers, wasn't the reality of what I experienced. And what I experienced on the shop floor was that the data available from these systems only scratches the surface of what's actually happening on the shop floor of manufacturing plants. And if you actually want to drive improvement, which is what everybody ultimately wants to do, engineers, managers, otherwise, you need to identify and solve problems that are only evident if you walk around and actually meet with people and see things with your own eyes. So here's this realization that data that people think paints the full picture is only scratching the surface. And that kind of opened my eyes early on in my careers, recognizing that to actually get value from data, you need to spend a lot more time thinking about human and people's roles in these systems. And that's something that isn't evident as a technologist. And I'd love to, in this conversation, sort of dive into what I'm most passionate about, which is really how to use data and use that to augment what people are able to do. And it's not replace, it's augment. And that's really my passion, is that combination of data, guidance, human ingenuity, mashing it all up together to make it possible for people to perform at levels never thought possible.
That's a very rich digital thread. And what I love about that is the, as you say, kind of mashup of those very specific domains and backgrounds. So as I mentioned, we just led your Series A round of investment at Raven.ai. And one of our strong theses is this idea of favoring those with deep industry expertise, i.e. the founders. And I must say, you and your team brought that in spades. I know you spent about 15 years in industry prior to starting Raven in 2015. You might have already spoken to it a little bit, but what would you say were the top 3 insights you gleaned from this time in terms or relative to IoT?
Well, that first one, I kind of alluded to it in what I just described there, but the fact that data from digital systems, whether it be data from your PLC or machines, even from ERP in manufacturing, so the data that you use to describe your performance doesn't describe why you are performing one way or another. And I think that realization was kind of one of the key things here, where the data from these IoT systems is hugely valuable, but doesn't explain why things are happening fully for you to understand the root cause of your efficiency or lack thereof. So the first thing really is this concept that there is information that is currently blocked on the shop floor that's in the minds of the folks working at the machines, that unless you find a way to tap it, you're never going to understand the problem enough to solve it. So that's kind of a key thing that likely encompasses a few different aspects of the problem we're talking about today. The second one is that when thinking about how to get value from these digital systems, it sort of takes for granted that once you have the right answer, or once you have this amazing insight, you're almost at the finish line and you're almost able to drive whatever improvement or gain from the insight. And I see a lot of content on the internet describing the goal is to obtain actionable insights. And I always think of, if you want to drive improvement with data, getting the actionable insight is step one of three. So in order to drive improvement, fundamentally, you need to get people to do things differently on the shop floor. So if you have this pure, complete, accurate data set that incorporates content from machines, insights from people, the next thing is you need to make sure that people perceive this data to be true. You need to make sure that folks on the shop floor trust it. And this element of trust is so critical and so important, and often overlooked by technology providers, because on the shop floor, if folks don't trust these digital systems, they're not going to take action. And in order to take action, the first thing is you need to trust that the data is true. You need to change their perception. In many cases, manufacturers had a long history of data that's just not complete, not accurate, not trustworthy. And I saw this when I was in manufacturing. You just show a report to an operator and you see their eyes roll. In your data, you don't see people's eyes rolling. That doesn't pop up. So if you can change perception, ensure that people trust the data, then you can hope to change behavior so that you improve performance. So really the two things here is like the data set that often manufacturers and other industries believe is the complete data set often only scratches the surface. And the second thing is that ultimately most organizations are today and will be for a long time fundamentally people businesses. And if you want to drive improvement, you need to find a way to change perception and drive behavior of people working at the front lines.
So if I were to summarize in terms of your step one, is really about providing context for the data. So not just the data itself, but meaning, if you will. Number two, making that meaning actionable for those who are empowered to do so, i.e. operators. And three, doing that consistently enough to create trust that the data is solid and the feedback loop in terms of their operations and such is known and trusted in that as well. And all of that really converging onto Raven.ai, which you founded in 2015. You refer to Raven's value proposition as automated contextualization and OEE software for manufacturers, excuse me. So for the lay people among us, can you describe OEE and then discuss what automated contextualization is in practice?
Yeah, so for OEE, and we don't need to get into the nuts and bolts of OEE, but fundamentally it's a measure of how efficiently you're using your equipment. How often when you are scheduled to produce on a particular machine or process are you producing? And the things that would contribute to low OEE are time lost because the machine's broken, because you're waiting for resources, because you're spending too much time set up. So it is an efficiency metric understood by manufacturers. I would say it's not far off a QB metric, where in football at the NFL, where people know that it's something you should focus on, but if you get them to show you exactly how it's calculated, you may get some differences of opinion. But fundamentally, it's a metric that captures performance of a particular manufacturing process. Now, in order to calculate OEE, and there's a bunch of other metrics that manufacturers use to measure their performance, you need to be able to categorize time. You need to understand how much time was spent producing, how much time was spent setting up, how much time was lost. So the starting point for that metric and many other metrics is a timeline. Now, in order to create a timeline, and you can think of a timeline as a general ledger. And this is something where if you're looking at financial data, your general ledger shows revenue coming in, expenses going out. And before beginning to draw insights from that kind of data, you need to make sure that you have fully captured all the ins and outs. And that's the starting point for Raven as well. So we want to understand how every second of production's time was spent. We can get some of this information from machines, but when the machines aren't running, you often need to get feedback and insights from operators. So you can just imagine that in a day, there is, say, 300 segments of time that need to be accounted for. So one of the challenges with many systems that do this, because manufacturers have been trying to account for time for a long time, is that many of these segments need to be categorized by people on the front lines. And one of the things that people on the front lines have a deep instinct for is the fact that their primary job isn't to account for downtime. Their primary job is to do their job, which is to help produce goods for the customers. So what happens is that many of these downtime segments that are needed to fill out this full accounting of what happened in the day are left unfilled because operators don't have the capacity or desire to distract themselves from their job to categorize that. So automated contextualization is effectively the ability to categorize or contextualize that segment of time without having to ask the operator questions. I always remember going back to my time on the shop floor of a manufacturing plant. We can get into this later, but when we were developing Raven, I always thought when you need to ask an operator a question with software, how would that question be perceived if you were standing next to the operator asking that question? Every 5 minutes, are you still in setup? Are you still in setup? So the idea here is that we automatically contextualize a significant portion of these downtime segments so that we minimize the burden on the operator. And the ultimate result is being able to categorize the vast majority of time, which is very difficult in our industry. And this is one issue that many companies struggle with. It's not complicated to calculate OEE. It's complicated to come up with that complete and accurate data set that feeds OEE metrics, but that also feeds other systems like ERP and MES that rely on complete and accurate data to be able to plan and operate the business and understand performance.
I know Rockwell recently has been using this theme of automation to augmentation. And it was interesting because you talked earlier about augmenting the operator, in some sense, automating contextualization, i.e., not requiring the operator to constantly answer, if you will. The system is, in some sense, augmenting them, right? And so I can see how all of these pieces come together. Perhaps to put a point on this, can you tell us a little bit about some of your notable use cases and wins?
And maybe just to go back to that augmenting, which is a key thing here, because in some ways, many systems view operators as a source of data that needs to be instrumented. And operators sense this. And in effect, what I alluded to earlier was the fact that a lot of these insights that can help manufacturers focus on the right things are in the heads of operators, are things that only they see. So the augmenting capability, one of the key things that we do for our clients and is a key thing that unlocks huge amounts of value is augmenting the influence of operators at the front lines. And when I say augmenting their influence, effectively, I always like to imagine that Raven is a way to give operators this long, pointy stick that if they need to poke a part of their organization to work on something or a problem that they see, it's their way to influence. And whether or not that's influence maintenance to come and fix an issue that they see now, or influence engineering to address a problem with process, or to influence the organization to purchase a particular piece of technology, really there's untapped capability, which is often categorized as this eighth waste. But the capability of operators on the shop floor who have access to data that you can't get from digital systems is massive. And in the context of Rockwell, it may be not exactly in the way that I've just described it, but there's huge capacity that's there to be unlocked and augmented by being able to connect the insights and ingenuity of folks standing in front of the process to the rest of the organization. So you asked about use cases for Raven. Once you are able to unlock these, insights from the front line, and create that fully contextualized, general ledger of time on the shop floor, you begin to see where the biggest opportunities for improvement are. And often what happens, and maybe I'll describe kind of the baseline. The baseline for many manufacturers is being able to account for, let's say, 80% of time. But that 20% of time that's not accounted for is, in some cases, half of the downtime, which makes it very difficult to know where to start and focus your efforts if you're trying to reduce downtime. So once our clients first see time that is contextualized, say 98% of time contextualized, they can see where their true biggest opportunities are. And often their biggest opportunities are a combination of things that are happening at the machines and in their process. So for example, one of the most common things for our clients to see is their biggest opportunity to drive improvement is related to a waiting loss. So a waiting loss could be waiting for maintenance to arrive at a machine, waiting for the operator to come back, waiting for somebody to move a part, waiting for resources. So these waiting losses wouldn't be seen if you are exclusively looking at PLC data. So one of our clients, part of Danaher, one of the issues they found, they were losing 1,500 hours per month waiting for maintenance to arrive. Now, once you identify an inefficiency as simple as waiting, organizations that have been leveraging lean manufacturing principles and understand how to drive improvements will address that relatively quickly. So the challenge isn't the capability to drive those improvements. The challenge is to really sift through all that data and find that lowest hanging for improvement. So now, for many manufacturers, the first issues that they see are these operational losses, too much time spent in setup, waiting for resources, issues with shift change. Now, as you begin to progress and address some of these operational losses, you'll get to the point where the natural next step would be to look to bring in best of breed technologies to address the next loss. And those kinds of solutions could be to bring in a robot or bring in a vision system or bring in something to bring your process to the next level. So really, the value that we provide is, simply put, helping manufacturers understand exactly what's happening now and has happened in the past, which is the first step to driving improvement, as part of digital transformation. You need to understand the basics before you jump to solving problems.
It seems like such a simple value proposition in some sense, but in practice, especially given the way automation systems have been developed, very complex to bring that out and, more importantly, to provide that contextualization in there. Let me ask, how do you know when an organization is ready to adopt your solution? And what are some of the best practice you've seen in realizing that potential value?
I think a lot of organizations are way more ready to digitally transform than they believe. And in some ways, this is because the kinds of conversations about Industry 4.0 that are most exciting are things that many manufacturers aren't ready for. So, for example, if we were to have a podcast about predictive maintenance, predictive performance, everybody wants to be able to predict the future and know what actions to take right now so that they can avoid future poor performance. So, which is kind of the bleeding edge of technology. And if you look at now, in order to get to the point where you're able to predict what's going to happen, you need to start at the basics. And the basics with regards to driving improvement with data, the first one is, do you know what's happening now? Do you know what's happened in the past? Do you have that complete and accurate data set to describe that? The next one is, once you have that accurate data, you need to analyze that data to uncover the reasons for why performance was good or bad. Then at that point, can you begin to take actions to address future performance? So now, if you were to go to the shop floor of any manufacturing plant and chat with their supervisors, with the plant manager, with operators, and talk to them about the value of being able to understand what's happening now and has happened in the past, that's something that many people can wrap their heads around. And you don't need to begin to talk about the next steps. How are we going to use this 2 years from now once we've addressed all of our inefficiencies? So by starting things in a way that's understandable to the shop floor and understandable to operations, it's much easier to create engagement. And once you have engagement and you have the commitment to make efforts to drive improvement with technology, those are the two ingredients that you need to drive improvement with Industry 4. And I think in some ways, a lot of the narrative around the barriers for Industry 4 adoption are around technological capabilities that are lacking in manufacturing plants. And I think that in some ways gives a pass to technology providers that have made technology that's too difficult for manufacturers to adopt. So manufacturers know how to drive improvements if pointed in the right direction. So as it is with any initiative, you need to start with the basics. And one of the basic things for anything that requires people to change is you focus on change, you focus on engagement, you focus on getting folks who are actually using this on board. So for us, manufacturers that have already demonstrated the ability to drive gains with lean manufacturing principles, who have an engaged shop floor interested in solving problems, that is the barrier. And that's the thing that we look for in our clients. Technological capability, that's something that should be the responsibility of technology providers to make sure that their solution is, from a user perspective, simple enough for folks in manufacturing to understand. There's extremely high value in things that are obviously useful to the front lines. If it's obviously useful, people will use it and they'll get value from it.
Now, we've talked a lot about manufacturing, and the initial use case for what you guys have done was certainly enough for us to warrant an investment because we know firsthand the needs around factory floors, especially in this, as you said, Industry 4. But even as we move to Industry 5, at least the way the EU sees it, where people and planet are now woven in, if you will, to the overall thesis of productivity. But I think what we were really pleased to see in a lot of the due diligence we did is that you seem to be having actually an even greater impact on supply chain, particularly as I remember warehouse operations. So can you tell us a little bit about this use case?
Yeah, no, so we're supporting a very large, well-known organization with their warehouse or shipping operations. And the application in particular is looking at what's happening at the loading dock. So, trucks arrive in the loading dock, the door opens, people unload and load trucks, or in this case, it's unload trucks. And it's a challenge today to get folks to work in loading docks and to do that in an efficient way. And so what we're doing with this particular application is helping them to understand what is happening at that loading dock door. Are they unloading a truck? Are they waiting for somebody to bring them paperwork so they can begin to unload the truck? Are they waiting because they don't actually have the forklift? So what is that story of the day? If you were to stand next to the operator all day, I think this is kind of one of the things that I recognized when I worked in manufacturing. If you had a plant manager standing or an engineer standing next to each operator, what are all the things that engineer would see and what are all the things the operator would ask them to do? And you can just imagine how efficient that operator would be if they had their own engineer looking at the process in that way. So in this warehouse application, we're helping them to understand how time is spent. And the ultimate result is that they understand where they are inefficient and are able to now produce or process a greater number of trucks with the same amount of resources because they understand where their inefficiencies are. So I think what this highlights is that there's many different types of process in manufacturing and outside of manufacturing that benefit from understanding how time is spent. And if you truly understand when time is spent productively, when time is lost, it is relatively straightforward to go address the issues once you understand. You need to define the problem. Once a problem is defined, there's a quote, it's almost more than half solved. So this application, manufacturing is our core. We understand it. Supply chain, huge opportunities. During the pandemic, we supported some hospitals in Nova Scotia with an application to watch how time was spent in an OR. For us, this contextual timeline or this general ledger for time is applicable in manufacturing, but it's applicable in many industries. And the challenge for many organizations is being able to construct this contextual timeline with hard data from digital systems and mushy data from people, and then present it back to those people in a way that they trust and understand.
Yeah, fully agreed. And thus, I think was the real long-term interest in you guys, because I think this area, call it, process optimization in some sense, has applicability to quite a few domains. And I was happy to hear about the hospital one as well, because I've seen several attempts at applying lean effectively principles to hospital operations as well. Let me ask, where do you see the greatest opportunity areas for this, I'll call it process optimization in the next 5 years?
Well, it's exciting in manufacturing to be able to drive improvements on the shop floor. But in some ways, if you look at manufacturing organizations as a system, optimizing one area of the system does not necessarily optimize the system as a whole. What's exciting to me is as these different areas of organizations begin to adopt best of breed technologies to improve performance, the idea that some of these systems begin to connect to one another. And then rather than isolate, optimizing in corners of the organization, you optimize one thing. And really, what needs to get optimized for manufacturing organizations is you need to optimize that flow from the operator helping to produce the good at the machine all the way to the consumer making that transaction at the store or on the internet. And I think I've always said that it'd be great the day that, the kinds of software that we're talking about today is an app on the Shopify store for Shopify vendors to simply optimize their operations. The idea that we have all the data, it just needs to be connected together so that there's one data set that captures an organization. And once you have that, huge opportunities to drive efficiencies. And if you're able to drive efficiencies, operational efficiencies like I've described, one of the effects of this is that you can likely now move away from having massive manufacturing facilities located in a few locations around the world. And now if you're able to do things in a much more efficient fashion, you can have more localized manufacturing because you're able to do things in a more nimble and efficient way. So I think this sort of also links to some of the stuff that we do with our Industry 4.0 club, is we're excited about how Industry 4.0 has the potential to improve profits for manufacturing, absolutely, but also improve the experience of frontline workers, improve the experience of consumers. And by making things more efficient, that also makes things more sustainable. So I think in some ways there's a win-win-win scenario here if we can get the organizations to adopt Industry 4 in the way that it can be, if people look at it in a holistic way rather than a tool to provide localized efficiency gains.
It reminds me of is back in my control systems and engineering day, one of the earliest books I read on manufacturing process was the famous The Goal by Ella Goldratt. And as you may remember, Theory of Constraints, it was called at the time. But there was some other names that I thought was interesting. Congestion theory, throughput management. And it all had to do with effectively manufacturing shop operations. And about the time you open up a limit in the flow on some machine tool, the rest of the process is the limit's just going to change to another part of the process because it's all a flow effectively. And in essence, it's interesting. We call it Industry 4 or 5. There's lots of topics, but the general theories have been well established for decades. If you go back and look, I think it was 1979 when the first part of that was written. So you mentioned a moment ago the Industry 4.0 Club, and I'm glad you brought that up because I'm really curious. So when you're not running Raven.ai, because we're an investor, we know is you should be doing 200% of your time. But during that 1% that's left, I know you're running the Industry 4.0 Club. So the mission is accelerate the evolution of Industry 4.0, delivering better experiences to consumers, better profits to manufacturers, and better jobs for factory workers. Tell us a bit about this passion and community you've developed.
Yeah, and I just want to sort of start off saying that I'm a co-founder of that club, and a lot of stuff happens based on the efforts of others that are driving that. But yes, the club came about kind of around the time when I met you, where we're all stuck at home because of COVID, and was reaching out to begin to connect with people on LinkedIn first. Then we started connecting on Clubhouse, and effectively there is a huge community of folks who are interested in Industry 4.0. And in some ways, because the pandemic made it so much easier for us to connect digitally, and we leveraged some of the things that were taking off at the time here, we were able to create this global club of folks who are interested in talking about Industry 4 in a way that could help move things forward. So, it started off, I remember being in a Clubhouse room with just myself, and then I pinged somebody on LinkedIn to join me. And then within a month or two, we had rooms with up to 5,000 people listening in, collaborating with Hanover Mess and IoT World and other organizations. So it grew very quickly. And now it's over 20 co-founders. We collaborate with events around North America and Europe as well. And it's exciting to have a group that is focused on, driving meaningful change. And the group itself has representation from the manufacturing plants. We have somebody who's a supervisor at a medical device company. We have representative from tech. So really, in order to drive meaningful change, it has to be with groups that represent different players in manufacturing, which our group does. Yeah, it's been exciting to get to know the other co-founders, and it's been exciting to sort of see the reaction and the interest from folks around the world in Industry 4 in particular, but really in the kinds of changes that Industry 4 can bring in. And a lot of people have an appetite for doing things in a different way. I was at a conference a couple of days ago with one of our clients and describing that when he hit the shop floor, he was shocked to see things being done in the way that he's pretty sure that it was the same as when his grandfather was there. There is a better way. And in order for us to break through and change the perception of manufacturers of what they can achieve with this kind of technology, this problem needs to be addressed in multiple ways. So Industry 4.0 Club is really about talking about the potential, talking about our excitement and some of the challenges to get manufacturers to adopt Industry 4.0 in a way that will benefit them. So it's been a great experience. I spend as much time as I can there, but as you mentioned, quite busy with Raven. So yeah, if anybody listening wants to check it out, Industry 4.0 Club, we have events both on LinkedIn. I'm not sure if on Clubhouse anymore, but we've also started to participate in events live as well.
Excellent. And, while these seem like different activities, they're actually quite complementary and both speak to your role as a connector. And I mean that in the sense that all stakeholders, not just executive ones, but frontline workers, if you will, the mid-tier managers, everybody that has really kind of a stakeholder potential in the problem set you're including, reaching out to. And it's interesting to see how the software and the club actually have a pretty close alignment on that. In closing, I always like to ask about your own personal inspiration, books, etc. How do you find your day-to-day inspiration?
I love seeing when people are able to perform at high levels, whether or not it's sports or in business. It's exciting to see people who have figured out how to perform at a high level. And to do that, it's one of the things that is exciting with technology is that in order to perform at a high level, folks, in some cases, it doesn't have to do with your natural capability. It has to do with your understanding of the process and access to information. And the example I always love to bring up is Alex Honnold, the climber there from Free Solo. I don't know if you've seen it, but if you think about what that guy was able to do, he was able to climb massive rock face without any gear. But there's nothing different from him and somebody who was a climber 200 years ago. What's different is access to information. So while he was training, he was able to get all of the insights from climbers from around the world. So the idea that with technology, he was able to perform at a much higher level, this is the same thing that excites me and motivates me when thinking about myself and my day job. The ability to use technology to make it easier for people to perform at a higher level. Effectively, the use of technology to commoditize excellence. I just love hearing stories of people who are performing at a high level. And when they describe it, that it's not magic, it's process. It's really exciting. I think that's something that drives me both personally and in my business. What can we do for myself to perform at a high level and to enable others to perform at a high level and use technology to achieve that?
I love it. Commoditizing excellence. I think I found the subtitle for our podcast. That's a great one. So Martin, thank you for sharing this time and these insights with us today.
Thanks for having me, Ken.
Absolutely. It's been a real pleasure and a great conversation. So this has been Martin Cloake, CEO of Raven.ai, commoditizing OEE excellence in manufacturing and supply chain. So thank you for listening, and please join us for the next episode of our Digital Thread podcast series. Thank you and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at Momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.